Hello, I am Chris Castro from the University of Birmingham in the United Kingdom. We research about educational psychology, cognitive psychology, embodied cognition, multimedia learning, STEM learning, gender differences in STEM. So those are kind of my topics. My methods are quantitative and experimental. So today I'm going to be talking about a quantitative and experimental paper. And I choose this paper because the topic is very timely. It's about learning styles, but beware, we all know that learning style is a myth. So this paper adds why it's problematic to perpetuate this myth about learning styles. So let's have a look at this paper. As you can see, the title of the paper indicates that there's this myth, learning styles, so we have to be very careful about this myth. And in this study, it shows why we have to be careful, because it affects the thinking about, so the opinions that parents, children, and teachers have. Here is the journal name, Science of Learning, belongs to the group of Nature journals, open access. Here are the authors. If we go down, we can see that these authors are from Canada and the USA. The usual format of this type of nature journals is that they have the introduction and then the results immediately, and then at the end they have the methods. So after the discussion you find the methods, in this case of the 3 different experiments. So this is not very typical of educational psychology journals. Usually in those fields we have introduction, then method, then results, and then discussions. What you should do before approaching any paper: first you read the title, and then the second thing you read before going into having an overview of the sections is reading the abstract. So in this case you can see in this abstract that it's saying that how the different samples that were recruited in each of the 3 experiments are doing this, are thinking about the academic potential of the children. And why is this a complicated thing? Because it's fitted by learning styles. If we follow the typical structure of educational psychology or educational psychology journal, we start by the introduction. In this case, the authors are making the point of why it's wrong to think about learning styles. And they tell us, you can see they're highlighted here in the top, that the most common model of learning styles is this one: VAC, visual, auditory, and kinesthetic. So that discriminates between these 3 types of students. And they also tell us that this is an issue not only because it can involve that teachers, for example, lose a lot of time trying to do these 3 different types of design according to these 3 different types of students. So it's not only a waste of time for the teachers, but it's also, as we are going to see in this paper, that there are other things problematic of using, in this case, the VAK Learning Styles Inventory. If we continue with the typical order of an educational study, we can go to methods. So in this case, experiment 1 gives details about the children, and these are very important details to report. So we have percentage of female versus male, the mean and standard deviation of the age of the children, so they are around 9 years old, and the range is from almost 6 to almost 13 years old. Then a page later you can see that there are 94 parents, so those are the adults used for experiment 1. Students and parents were given this type of images while telling them the story. In the left side you can see that they were telling them, okay, we are going to be talking about this child, which is a visual child, so you can see that image on the left, and on the right they told something similar to the participants. So we're going to talk about the child. In this case is a kinesthetic child, and then they asked them several questions regarding how smart or how sporty they thought this type of children were. It's important to note that the researchers did a very good decision here. Instead of using kinesthetic, which could be a little tricky words for children especially, they mentioned hands-on participants. This is experiment 1, figure 1 in the paper. So you can see here I'm showing the child rating. So how the child rated if the student, the hypothetical student that they saw, is smart or sporty, depending on the learning style. The y-axis shows the rating that these students were given. It was a scale from 1 to 4. 1 was not very smart, 2 sort of smart, 3 smart, and 4 really smart. So we're talking about smart, but this also happened with sportiness. In the x-axis, we can see these two categories, smart or sporty. I'm showing now the legend, so you can see that hands-on is in black and visual it's in gray. The top of the bars in a bar graph usually show the mean, as in this case. So we're seeing the mean of the 4 different conditions in red now. So you can see that there are differences. But we also need to consider this now in red, which is the standard error of the mean. The standard error of the mean and the means, you have to think about those in combinations. For example, I'm showing here, when you are comparing 2 bars and you are considering the standard error of the mean, you have to consider what I'm showing now on screen. For example, the shortest bar in its most up position according to this standard error, and the tallest bar in its shortest position. So something like this. So in this case, if you imagine that the black bar goes up until up to that red line, and the gray bar goes down to that red line, still there will be these differences in that visual. It's being rated higher in smartness than hands-on. So this is an indication of significant findings, because even though you consider all the range of the standard error of the mean, still the bars are showing the same difference. In contrast, in non-significant differences, I did the same exercise here for sporty. So the upper bit of visual surpasses the lower bit of hands-on, as I'm showing here in red. That means that the order of the bars, so black being taller than gray, it can be reversed. So this is a visual way of telling, okay, maybe these differences in sporty are not significant because the bars change which is taller than which. So these are visual ways of telling, okay, maybe these 2 bars are not significantly different. So you can see that in smart, visual students are seen as more smart than hands-on kinesthetic students. And in sporty, we see the opposite trend, although this is not significant. When we see the results of the parents, very similar, so we have also this significant difference here. They say that visual learners are significantly more smarter than hands-on learners. And here there's also significant difference that we didn't see in the we saw the same direction of effects in children, but here in parents the difference are significant. So they believe that hands-on learners are significantly more sporty than visual learners. So what we found in experiment 1 was that both children and parents believed that there were differences between hands-on and visual type of learners regarding being smart and being sporty. In experiment 3, the sample included 100 parent participants and 100 teacher participants. And you can see here the details of the sample. An interesting addition of this experiment 3 is that the students had to be ranked according to non-core or core topics in the school. I'm showing you now one of the main graphics of experiment 3 shows how these effects could be different if we do comparisons between non-core topics, arts, music, and gym, versus core school subjects, math, science, language, for example. So those core subjects, participants believed in this experiment 3 that visual learners will do better, significantly better, but for the non-core type of studies, so again art, music and gym, hands-on students will do better. In experiment 3, this case you can see visual. Both parents and teachers believe that visual students are smarter than hands-on students. This is a new type of question. Which student works harder? So both teachers and parents believe that hands-on students work harder than visual students. We get into the discussion section, and I did a very brief overview of experiment 1 and 3. You can go to the paper yourself and have a look at experiment 2, and of course read in more detail the 3 experiments. But this is the discussion section concluding. So we can see that parents, teachers and children believe that students that we can regard as visual are more intelligent than children that we could describe as hands-on learners. And the visual learners will receive higher grades in the core school subjects, but the hands-on learners will be more skilled or having better grades on non-core subjects. And we also saw that this last graph, for example, showing us that hands-on students will work harder than visual students. So what are the important implications of this paper is, as I'm showing there, highlighted, it's not only wasting efforts of the teachers to be doing these comparisons of these measurements of learning styles, it's also concerning because it may make a host of specific and unwarranted inferences about the academic strength of children regarding, for example, being smarter or not, being sportier or not, and being more into working hard or not. So to conclude, the problem that this paper helps us finding is that learning styles are not only perpetuated by teachers but also by parents and by other children. And it's very problematic because we are saying that because a child is regarded as hands-on, then that child is more into working hard and more into sports or doing better in non-core academic disciplines compared to what we can regard as a visual student, which will do better in core disciplines, which will be regarded as smarter and working less hard. Thank you for listening me trying to explain this quantitative experimental research paper, and I hope you go have a look at all the graphs that I didn't mention and all, of course, the text and the analysis. It's a very interesting paper because it's another evidence that we shouldn't be considering learning styles.